Hello students, welcome to Lucky Learning. Here in this video, I am going to explain you Booth. Booth's multiplication algorithm is very important as concerned with your semester exam. Here are some of the screenshots where I can show you the question Booth's multiplication algorithm is asked in previous year papers. So here is a question in August 2022. Explain the Booth's algorithm for signed multiplication. It's also called signed two's complement multiplication. And here also you can see why with an example explain Booth multiplication algorithm. So Booth's multiplication algorithm is very important for your exam point of view. So don't neglect. Listen to the lecture carefully. Booth's multiplication algorithm gives a procedure for multiplying binary integers in signed two's complement representation. Booth's algorithm will perform multiplication of two numbers if the numbers are treated as in two's complement representation. The algorithm, what it uses is based on two facts. The first fact is a string of zeros in the multiplier. So here I have to explain what is a multiplier and what is a multiplicand. Say if you perform A into B, now we can call B is multiplier and A is multiplicand. A string of zeros in the multiplier requires no addition but just shift, because whenever we have to perform multiplication with zeros, multiplying a bit zero with multiplicand will makes no difference. So what it requires only shift. And the second fact is a string of ones in the multiplier from bit weight 2 power k to 2 power m can be treated as multiplying the number with 2 power k plus 1 minus 2 power m. Let me give an example. Suppose I have a number a into 14. Suppose a is some number that is to be multiplied with 14. Now 14 in binary, it is to be represented as 0 triple 1 0. 0 triple 1 0. Now what is 0 triple 1 0 is called 14. Now 14 can be write as 16 minus 2. A into 16 minus 2. It means A into 16 minus A into 2. Right? A into 16 minus A into 2. Now how I know that it is 16 minus 2? Look at, I have taken 14 as 0 triple 1 0. The bit weight for this bit is 3, this is 2, this is 1, and this is 0, this is 4. Now whenever string of ones are there, now it is a meaning that the multiplication is with respect to 2 power 3 plus 1 minus 2 power this bit position. It is 2 power 1. 2 power 3 plus 1 is called 16 minus 2. It is called 16 minus 2, which is equals to 14. It means whenever there is a string of ones, so simply what we can do is whenever the first one you found it, means that least significant one you found it, you perform a subtraction. Subtraction of multiplicand from the partial product. Whenever the most significant one in the string of ones, the last one whenever you find it, then you have to perform addition of the multiplicand with the partial product. It means whenever you have seen 1 0 and you have to perform a subtraction, whenever you see 0 1 you have to perform addition, and wherever there is a string of ones or string of zeros you have to perform only shift. So it means, suppose if you have some number like this 0 1 1 1 0 0 0 0 1 1 1 1 0 0 1 1 0. Suppose this is a bigger number. This multiplication of bigger number can be done by using a string of zero signed ones where this is representing number. In this, I'm assuming there is a string of ones and string of zeros are there. Wherever string of ones and string of zeros are there, if the previous bit I'm calling qn plus 1 and the current bit I'm calling qn, then it requires to perform a subtraction. Whenever the previous bit is 1 and the current bit is 0, it requires to perform addition, and the remaining times it requires to perform a shift. Again, you can look, it is 1 0 means it is for performing subtraction, and 0 1 means addition, and string of ones, it means it has to perform a shift. And moreover, wherever you perform a subtraction or addition, then you have to perform a shift. Shift is compulsory always. Every time when you perform a shift, the number is multiplied with 2. Because this 14 is not in the powers of 2, it has to shift and perform a subtraction. Means multiplication is implemented using shift and subtraction and addition. So what you can see here, there is a sequence of zeros. We have to perform a shift, and whenever 1 0, it requires to perform a subtraction. Sequence of ones, we have to perform a shift, and 0 1, it requires to perform a addition. So what we understand with this, whenever you have a qn and qn plus 1, if qn and qn plus 1 are 1 0, it requires to perform subtraction. Whenever qn and qn plus 1 is 0 1, it is to perform addition. And whenever qn and qn plus 1 are both zeros or both ones, it requires to perform no subtraction, no addition, just it has to perform shift operation. So here you observe, wherever you have 1 0, you have to perform a subtraction, perform shift. 0 1, perform addition, perform shift. 0 0 1 1, no operation but only shift is required. Based on this, we have to perform multiplication of two numbers. Now look at shifting and addition subtraction rules for multiplicand in Booth's algorithms. That rules are, the multiplicand is subtracted. Look at the multiplicand is subtracted from the partial product upon encountering the first least significant one in a string of ones in the multiplier. First least significant one in the string of ones, it means that previous bit is 0. It means when previous bit is 0 and the first least significant bit is 1, then it is going to perform a subtraction. And the multiplicand is added to the partial product upon encountering the first 0, provided that there is a previous 1. Then in such cases, it has to perform the addition. And a partial product does not change when the multiplier bit is identical to the previous multiplier bit. Identical means both zeros or both ones. Then any changes is to be done. So does not do any changes. No changes. After you perform subtraction, addition or no change, it requires to perform a shift operation, right? Now here we will see hardware implementation of Booth's multiplication algorithm. How hardware implementation is to be done? Suppose I am performing x into y. Now x is called multiplicand and y is called multiplier. To perform this multiplication, it requires to store multiplicand in one register, multiplier in one register. And what register is required for storing multiplier? For storing multiplier, I'll be using some register called Q register, or we call QR register. For multiplicand, I'm using BR register. And after performing the multiplication, the final result is stored into AC, QR registers. Means two registers are used together to store the result. Why two registers? Why not one register? Because simple example I'll tell you. When you perform a two single digit numbers multiplication, then the result is 9 into 9, 81. Means when I'm performing multiplication of two one digit numbers, maximum I can get two digits. It is a meaning that when two n-bit numbers are multiplied, you may expect maximum value is 2n bits. 2n bits. 2n bits means AC and QR register both are required to store the result. Now look at multiplicand in the BR register, multiplier in the QR register, and result is in together AC and QR register. Together AC and QR register. And here multiplying with multiplier is required, and every time it has to check the string of zeros and string of ones are 0 1 or 1 0, and it has to be repeated the process of addition shift, subtraction shift, or only shift. This operation is to be repeated for n number of times, where n is the number of bits in the multiplier. That number of bits in the multiplier is stored in the sequence counter. The sequence counter is called SC. Now, what operations we are doing? We are performing addition, subtraction, shifts. So, to perform addition, subtraction, and shifts, it requires parallel adder, and performing subtraction, it requires a complementer, because we know that a minus b we can perform by performing a plus of minus b. What is minus b? 2's complement of plus b. So that we requires a complementer. And what is recommended whenever 0 1 is there, we have to perform addition of multiplicand with the partial product. And AC is to store the partial product. Initially, the partial product is all zeros. Suppose if I am taking 6-bit number, 6 zeros are required. If it is 8-bit number, 8 zeros are required. And 0 1 means it requires addition. Addition means the multiplicand is added with the partial product, and the result is stored in the AC register. Whenever it is 1 0, it has to perform a subtraction. How subtraction is performed? By taking the complement of multiplicand, and this is to be added with the partial product, and the result is stored into the AC register. Whenever the two bits are identical, whenever the two bits are identical, both are zeros or both are ones, when two bits are identical, it has to perform only shift action, and even addition or subtraction. After addition or subtraction, it also requires shift action. So what is to be shifted right? Accumulator contents and QR registers are to be shifted right. Whenever shifted right, the least significant bit in the QR register, that is called multiplier, is called QN, that is shifted right, and that shifted right bit, that QN bit, whenever shifted right to this, I can call QN plus 1. So every time these two bits are going to be compared, based on these two bits, we have to perform the multiplication. As I told you, 0 1 for addition, 1 0 for subtraction, 0 0 1 1, no action, only performing a shift. Okay, so this process is to be repeated. Addition, subtraction, shifts. This process to be repeated for n number of times, where n is the number of bits in the multiplier. That n is stored into the sequence counter. Whenever sequence becomes 0, we have to stop the process. Now look at the hardware algorithm for signed 2's complement data. The multiply operation requires multiplicand in BR register, multiplier in QR register. Here, initially Qn plus 1 is 0, and partial product is 0, and sequence counter is set with n. What is this n? N is the number of bits in the multiplier. Now here it requires to check two bits. Qn is called least significant bit in the multiplier, and Qn plus 1 is the previous bit. Initially previous bit is 0. And these two bits, when are same, when are identical means both are zeros or both are ones, it has to perform shift right, accumulator, and QR register. But here you observe what is their ASHR. ASHR is called arithmetic shift right. In arithmetic shift right, it is a meaning that the sign bit will be as it is, including the sign bit, it is to be shifted right. Let me give an example. 0 1 1 0 is there. This is a sign bit. Sign bit is unchanged, including the sign bit, it is to be shifted right. Means 0 comes to this position, 1 comes to this position, 1 comes to this position, this 0 will be out. This is called arithmetic shift right. So sign bit at the same position, sign is not changing, and included side it is going to be shifted right. That is called arithmetic shift right. After that, it has to perform a decrement of sequence. And if sequence becomes 0, means process is completed. The product is in AC and QR. Suppose if the Qn and Qn plus 1 are 0, 1. What is it meaning? The previous bit is 1, the current bit is 0. It is meaning that it has to perform what? Tell me. It is to perform addition. How addition is to be performed? AC plus BR, result is to be stored into AC. After that, it has to perform arithmetic shift right, AC and QR. Again, sequence is going to be decremented. Then check for the sequence is 0. If it is 0, and the product. If it is not 0, then you have to repeat the process. In the repeating the process, you have to check Qn plus 1 and Qn. Qn plus 1 and Qn are 0, 1. Like here, 1, 0. 1, 0 means it has to perform a subtraction. How subtraction is to be performed? AC plus 2's complement of BR. AC plus 1's complement of BR plus 1 will give you AC plus 2's complement of BR. That is subtraction. After subtraction, it has to shift right, AC and QR, and sequence is to be decremented. If sequence is not 0, this process is to be repeated. How long it is to be repeated? Until sequence becomes 0. Until sequence becomes 0. If sequence becomes 0, we have to stop, and the product is in both AC and QR register. Now here we'll see one numerical example so that you can understand very easily. Here I'm taking some multiplicand value. That is BR is 10111. What is 10111? Look at here, the sign bit is 1. Sign bit is 1 means it is a negative number. To get its positive value, take the 2's complement of this number. How do you take the 2's complement of this number? The least significant one is unchanged. Remaining bits are going to be changed. So means what is this value? This is plus 9. It means what is this value? It is a minus 9. Multiplicand is minus 9. Now, it means it is a question for multiplication of minus 9 into minus 13. So we are expecting result should be plus 117. Now look at Qn and Qn plus 1. Initially Qn plus 1 is 0. Initially Qn plus 1 is 0. It requires to check the multiplier Qn bit, means least significant bit of multiplier. Where is a multiplier? Multiplier in the Q register. Look at here, initially multiplier in the Q register. This is a minus 13, 10011, 10011. In the sign bit 1 is there, means it is a negative number. To see actual value of this negative number, take the 2's complement 1, and this 1 becomes 0, 1, 1, 0. This is plus 13. It means that this number is called minus 13. So multiplier in the QR register, multiplicand in the BR register, BR plus 1, BR complement plus 1 is called plus 9. Okay. And what is to be verified? Initially Qn plus 1 is 0 and sequence is 5. Here we can write decimal 5 also, no issue. What is a Qn bit? 1. Qn plus 1 is 0. Whenever it is 1, 0, it has to perform a subtraction. Look at Qn is 1, Qn plus 1 is 0. Then it has to perform a subtraction of multiplicand from the partial product. So subtraction means how do you perform a subtraction? Using the addition. So what is a multiplicand? Multiplicand is minus 9. So that is to be added to the partial product, means subtracted from the partial product. So minus of minus 9 will become plus 9. Simply you can go with addition of this partial product with complement of multiplicand. That complement of multiplicand is plus 9. That is to be added. So that you will get 01001. Now, then you have to perform arithmetic shift right. Arithmetic shift right means you are going to get this value. Look how you got this value. Now this sign bit is as it is, including sign bit, it has to be shifted right, right? So means you are going to get the value like this, and this one comes here, and then after that it has to decrement the sequence from 5 to 4. Now this completes one step. Now you look at what is Qn and Qn plus 1. The Qn and Qn plus 1 are 1 1. When both Qn and Qn plus 1 are 1 1, anything requires to be done, addition or subtraction? No, it has to perform only shift right. Shift right means you are going to get these values. It means including the sign bit, it is to be shifted right. So sign bit will be as it is. There is arithmetic shift right, so that this is going to be the result. Okay, fine. Now sequence is going to be decremented to 3. Now what is a Qn bit? 0. Qn plus 1, 1. If it is 0, 1, then what you have to perform? Adding BR to accumulate. Now what is BR? Minus 9. Minus 9 is 10111. This is to be added. Whenever it is added, you are going to get 11001. Now this 11001, just for the reference I am writing 011001, including this AC and QR, it is to be shifted right. Shifted right means including the sign, it is to be shifted right. Sign bit is at the same position, including the sign, it is to be shifted right. Including, it is to be shifted right. Look at 0 1 1 0. This one, this 0 comes to this position, and this one is going to be out, correct now? And sequence is decremented to by 1, so it becomes 2. Now look at both Qn plus 1 and Qn are zeros, then it has to perform arithmetic shift right. So because no change, you are going to get this value, because including the sign, we are shifting right, right? This is a value, and this is going to become 1. And because sequence is not 0, it is to be repeated for one more time. Now what is the Qn? 1. Qn plus 1 is 0. 1 0 means it is to perform addition or subtraction, it is to perform subtraction. So subtraction, it is to be performed. Subtract BR from accumulator. What is a BR? Minus 9. So subtracting minus 9, minus of minus 9 plus 9, adding this plus 9 to the partial product, you are going to get this result. And this result is to be shifted right. Whenever it is shifted right, we are getting this value. Now sequence becomes 0. Once sequence becomes 0, we have to stop the process, and the final result is in AC and QR. Now what is the value in the AC and QR? Look at this is a value in AC and QR. Whenever you can find its decimal equivalent, it is plus 117. Why it is plus? Because sign bit you observe, sign bit is 0, it is meaning that plus, and the magnitude it says 117. This is how multiplication is performed using Booth's multiplication algorithm. Hope you have understood. Thank you so much for watching this video. Please do like and share, and don't forget to subscribe. If you like the video, please share with your friends. Thank you.